Today we're going to look at the third set of posters, which are the Emergent Posters. This is the set that you would use for students that are a little more advanced in their practice of designing their own experiments. I'm also going to use the tried and true jar over the candle experiment as a way to demonstrate this. Now, how I would start this in a class would be, I would ask for quiet. I would hold the jar over top of the candle, asking students to make their observations as they gather around. Now, I'm also asking them to be quiet and how we have to wait for Johnny to settle down before we can actually do this experiment and explain about how important it is. What I'm really doing is stalling for time, because what I want to do is I want to get the jar as warm as possible before lowering it on top of the candle. So that's the idea here. So again, students are rustling and they're I'm telling them how important it is to be quiet and to use all of their senses to make their observations. So I think we've got this sufficiently held over top. You may also notice there's a little bit of condensation coming over top of the jar. Once it starts to warm up, then I lower the jar over top of the candle, asking students to watch very carefully. Okay, so now they're making their observations. Once the students have had a chance to observe the water in the jar over top of the candle, then they're asked for their observations. So we're using the third set of posters, which starts with the starburst, moves to a brainstorm, and finishes with Fishbowl posters. This again in our series, in terms of development, is our emerging through to proficient. In the center of the starburst for the first poster is a spot for the object or the situation. I have these posters up on my wall. The students have 8.5, 11 versions for them on their tables. So the first thing they'll do is on a post-it note, and they're using the same colored post-it notes that I am. In this case, it's yellow. We're talking about jar and the candle is the situation. And this is a way to organize their observations around the outside of the starburst. So what they will come back with, again, it's important that the students share their observations, that I as a teacher don't tell them what they saw or what they were supposed to see. The power in this process is that the students come up with it themselves. So what they will say is they'll notice that the candle went out. Okay. They may use language like the candle was extinguished or the flame was extinguished. Again, you don't try to put words in their mouths, you use the same words that they would use. They would notice maybe that there was some smoke that would come up. Again, that's a behavior that they would put here. Okay. While I'm doing this, there are some students that are racing ahead. I've told them to write down all their observations, one observation per post-it note. There's some that have 5 or 6 of them already completed before we even get to these two. There are other students that don't know where to start. They're waiting for me to write something on the board so they can copy what I've done. Most of the class is discussing or is providing me with ideas of post-its to put up here, so they're right with me. Again, what we've done is we've differentiated here for every student in the class. Another observation they'll come up with is that the water rises. Now that's the one that I want to hear, and I keep going until I actually get that from the students. Right? I may drop hints, but I don't tell them to focus on the level that the water comes up to. But that's the one I want. And it's important, it's very, very powerful, very empowering for the students when they can come up with that themselves. Okay? So I know the curriculum, I know where I want to go with this, and what I want to talk about is the level or the water rise in the jar. So that behavior, of all these behaviors, is the one we're going to focus on. What a scientist does, what scientists do, is they observe behaviors and then they select one to focus their attention on. That one becomes what's called the dependent variable of the study. So in this case, with this set of posters, we remove that single behavior from the starburst and put it in the bottom of the poster here. So the behavior of interest becomes the dependent variable, or the DV, for the study. So we'll make that. Now it seems silly But every class I've ever tried this with, from grade 4 to grade 12, they get the idea. It's this physical motion of the posters. I've had students that have tried just writing in. I've run it where they just wrote in the behaviors on the sheet of paper. But for them to rewrite, particularly those reluctant writers, they don't like to put anything down twice when they can just do it once. They get this physical motion into the one spot. Okay, so now their job is to, I turn it back to the students, and their job is to get the water, because that's going to be the dependent variable. They need to reproduce what I just did. They need to get the water in the jar to rise to the same level as I did in my demonstration. So the students all tear off. There's jars, there's candles, there's water, there's different classroom management things that you're going to have to attend to depending on the level and the age and maturity of the class that you're dealing with. But it's important that they get their hands on the equipment and that they practice, and your job then as a teacher, or my job as a teacher, is to walk around and troubleshoot to make sure that they're being safe and that they're setting things up, but rather than telling them what to do. Typically what happens is they cannot get the water to rise to the same level as the demonstration. So after repeated questions about how did you get it to do that, I say, all right, I capitulate and say, all right, I'll do it one more time, but you have to watch. The next time I do the demonstration, however, I hold the jar over top of the candle without saying a word, and I just wait for the jar to hold there. What'll happen is that some kids get it right away. They'll tear off. They know that they haven't been waiting very long, and they start discussing on who's going to count it, who's going to take so much time, who's going to record the amount of time that they actually wait over top of the jar. So from there, then once they've had, so then we can have a class set of the water level that each was able to achieve. So you can get students that do it, some groups are going to do it 2 or 3 times, others maybe only be able to get it once. But they have to come up with their own procedure for measuring the level of the water in the jar. Again, a junior group, you may just be looking at centimeters that it rises in the jar. Other groups, you may want to talk about volume and how you calculate the volume of water in an irregularly shaped jar. Whatever you use, you certainly will have a class set of data that you can use as your control set. You can then either project them on a screen and discuss as a class the reasons for the differences. Also, maybe you want to discuss how close is close enough. Do we want to all be within a half a centimeter? What would maybe be some of the reasons for the differences? So the class has the same sort of discussion that scientists have when they're trying to refine protocols, when they're all trying to make sure that everyone is doing things the same way all the time. Once we've had that discussion, then we move into, now we're actually going to do an experiment. We're going to build an experiment. They're going to manipulate something. So the focus again is on the water level. Okay, so we move to the second poster. That's the brainstorm. In the middle of the brain, just to know that our focus is here. We're actually focusing on the level. We refined it a little bit. So the water rises, but we're worried about we're going to concentrate on the level of the water that's rising here. Okay. In step 2, this brainstorming step, we're listing all the variables that may change the dependent variables of behavior. So we're looking at all the variables that may change the water level in the jar at the end of that experiment. Now, they've already had an opportunity. They've struggled with this. They've all tried to have the water rise to the exact same level, so they will know some of the issues they've had and things that may actually affect that water level rise. So they're going to come up with things like, again, they're all working at their tables with the same posters that I am here. They're using a different color post-it note this time. These are variables that may affect the water level. So we're talking about the time, the wait time that they would have. Okay, that would have come up. And we'll talk about the shape of the jar. They may talk about the size of the jar. They may also come up with the temperature of the water. They may talk about it's the type of liquid. They may want to change the liquid. All kinds of things can come up. Okay, so again, that's that brainstorming. So we troubleshoot or we brainstorm all of the things that may possibly have an impact on water level. Okay, so we've introduced the third poster in this series, and for this set 3, there are only 3 posters in this. And it's the fishbone. But before I talk too much about, or very much more about the fishbone, I want to talk a little bit more about the brainstorming poster. It's an important poster to leave in. We've tried this set 3 with only 2 posters, with the starburst diagram and then going directly to the fishbone. And this is a very important step for kids to get. They need to be able to do that brainstorming and look at, be able to discuss together and think about all the different variables that may affect their study or their dependent variable. That's an important aspect. The other important aspect I'm going to mention too is that if you noticed in the demonstration that I did, I used common household items. I used a Pyrex plate, just a plain glass cooking plate with water, candle, and a jar, like a regular pickle jar, basically, is what I was using there. And it makes the science more accessible. So often what we do in science experiments is we use fancy equipment like graduated cylinders and Erlenmeyer flasks and things that you just can't get your hands on if you're not in a school or in a science lab. And I also wasn't worried too much about making the demonstration absolutely perfect. In the past, when I was trying to do the official science demo, it had to work. And I mean, how many times have we been in and when the experiments failed, or what we say is failed, and resort to saying things like, well, what you should have happened was this. This approach, what happens, happens. And we're not worried about it being perfect every time, because the students are going to repeat it and they're going to manipulate it, and they learn by doing it. So we can make it so much more accessible by telling the kids to trust their observations and not us worrying so much about our demos being perfect all the time, and again, trying to use more household common items for them. Anyway, so we've had the students look at this particular candle over the jar. They are they're focusing on the water level that it rises to, and we're also using the pink Post-its, different color, to talk about the things that might affect that. All right, so moving to the fishbone now. The fishbone is designed so that everything leads to the head of the fish. The focus is on the head of the fish. That happens to be the dependent variable. So I'm going to move the water level from the middle of my brainstorm now. That becomes the head of the fish. Okay? So every student in the class, the way I've set this up, every student in the class is going to use this as their dependent variable. You can give students a choice. You know your curriculum. You can decide what it is that you want to become the independent variable. So all of these variables that possibly could affect the water level rising, you can pick one for the entire class. So we may want to look at the wait time, the time that they hold the jar over top of the candle, could be the independent variable here. You could just as easily have students select any of these, or you could do a subset of these that they could select from, so you could have different experiments going on in the classroom at the same time. That's quite helpful, especially if you've ever had the experience where you've got some groups standing around waiting to copy the data from other groups to let them do the experiment. I've had situations with 28 students working in pairs, so you've got 14 different experiments going on in the classroom at the same time. Nobody's waiting around to see what anybody else gets. All of the other variables here, the other pink Post-it notes, where we've already had the discussion about how they could possibly affect the dependent variable, the head of the fish. So the students already recognize that they have to keep an eye on them. They go around the outside of the fishbone here as our constant variables. These are the things that need to be held constant, so they go around the outside of the fish. So there's your experiment. You can now use writing stems. Okay, the purpose of this study is to look at the effect of wait time on the water level, the water level rise in the jar and candle experiment. Purpose statements, predictions, all that sort of thing can be run from here. The other thing I'm going to point out about the fishbone is the IUT. You'll see a spine that comes off of each of the main part of the fish, leading to each of these variables. It's listed with IUT, Instrument Unit Technique. This is the spot where the students can make jot notes or get down their ideas very quickly on the instrument that they're going to use, the units that they're going to use, and the technique they're going to employ. So what instrument will they use to measure the water level? Some of them may be using just a ruler or centimeters. Okay, what units? So they're going to measure in centimeters, millimeters, feet, inches, degrees Celsius. some kids don't know, right? So it's important that they write that down, and what technique are they going to use? So how are they actually going to hold that ruler when it's in the water? Is it from the top of the water level or from the bottom of the pan? Those are the things they need to discuss and come up with. Wait time. What units are they going to use to measure wait time? What instrument? Are they going to use a stopwatch? Are they going to sing a song? What are they going to do? Technique. Here they want to talk about what different wait times are they going to manipulate. Are they going to hold one for 5 seconds, another one for 30 seconds? Or are they going to do it in 5-second increments? How are they going to actually play it? So this is they're going to flesh out their study here. Just as well, what units, instrument, and technique are they going to use to keep all these other things constant? Okay. So the Fishbone then gives them a 1-page organizer for their procedure. Might I suggest that you resist the temptation to have them now write out a step-by-step procedure, line-by-line procedure in order. They've already done the thinking here, and nothing will take the excitement out of the room faster than have kids sit down and write down an exhaustive step-by-step procedure. They're keen at this point to get at their experiment. They've already thought it through. They know what they want to do, and it's organized. I mean, I've used this as their procedure. Right? I can walk around now and as they're going through their experiments and see very quickly what it is they've set up and what their plans are. Okay, it's actually easier for me to read this than it is to read through a list of procedural steps. The final thing that I will do before releasing the students to actually conduct their experiments is make sure that they have the data collection table set up for them. So columns, rows, however they decide to collect it. It's important that they design that table themselves the first few times through. You may want to model that with them, may want to work through it with them. There will be students in your class that need more support than others with it. But armed with their Fishbone and a data collection table, as long as they pass that by me, then I'm pretty confident that they're able to conduct a safe and good experiment.